Hello all, welcome to Excel Academy. So today we are going to see through the same problem yesterday what we did, but in a different manner. So different manner in the sense you have the x1 of n, which is equal to what? That is 2121. So please do try to understand what I am trying to tell, okay? So it is because these things are really important for exams, and I am going to help you crack the subject through the concept of examination itself, right? Yes, and you had 1, 2, 3, 4. So this one we did using concentric circle method yesterday. But now we are going to get the same resultant. That is, we got the resultant as 14, 16 and 14, 16. That is x3 of n is equal to x1 of n into x2 of n. That we got it as 14, 16 and 14, 16. So that you're going to get it by using DFT and IDFT methodology. What methodology? DFT and IDFT methodology. So this is what is the last methodology that you see, right? Yes. So this is what is the last method with respect to 4-point DFT, and we are going to see two more problems with respect to IDFT methodology, right? IDFT methodologies, that is what I can say, IDFT methodology using matrix method and using your what I can say this one, which one? That is your a formula method. These two, let us look at it. Okay, so for this two you don't have DFT and IDFT. It is directly a circular convolution using concentric circle method, and you have here only have DFT and IDFT method, right? Yes. So in that formula method as well as what I can say the matrix method we have done with respect to DFT. So now let us learn things with respect to IDFT, right? Let us learn things with respect to IDFT now. That is things with respect to IDFT in the sense. So we are going to learn those topics with respect to your IDFT methodology. We have learned with respect to DFT. Let us learn with respect to IDFT methodology, and now let us learn this method now. That is DFT and IDFT method, right? Yes. So now let me start with DFT and IDFT. This is what is whole and solely matrix method, right? This is completely a matrix method. This is DFT and IDFT method, that too a matrix method, wherein you have two formulas. That is what formula? My very first formula is what I can say, that is you are going to get your this one. That is which one? Your formula is x of 4 is equal to what I can say, your omega of 4 into x of 4, right? Omega of 4 into x of 4, and then so one more formula with respect to your IDFT is, that is your x of n is equal to what? Your x of n is equal to, that is 1 by n, that is 1 by n into, just a minute, I'm really sorry, wait a second, 1 by n into what I can say, the omega of n, the what I can say, the star into what I can say here, x of n, right? Yes. So these two formulas is supposed to use. So now here, please to understand. So we have two sequences, not one sequence. So for one sequence finding DFT, you know, right? And for the what I can say, the two sequence, you don't know how to find the DFT as well as IDFT. So for that, what you're supposed to do is, so you get a variable called as x3 of k. So what is x3 of k? So x3 of k is equal to x1 of k into x2 of k, right? So I don't take much time, students, for this, because you know what is DFT and what is IDFT using matrix method. We have done already things there, right? The same procedure it goes on. but some further more things has to be done. So I don't take much time with respect to this, and this particular is really important. You get a questions on this particular DFT and IDFT methodology. Yesterday only we saw with respect to two questions, that is circular convolution using DFT and IDFT method. Yesterday we saw two questions in the question paper, right? So that is why you have to practice more on this DFT and IDFT, the concentric circle method, the formula methodology, and the matrix method. Your matrix method is the most common method that he'll ask for exam, but sometimes he might ask you the formula method. Please try to do it. And the circular convolution using concentric circle and DFT IDFT is important. All these four is important. You have to practice it without fail with respect to 4-point DFT, right? Yes, you have seen that all the questions, most of the questions were from 4-point DFT only. You did not see any questions on 8-point DFT in yesterday's session, right? Yes, some few questions were there in 8-point DFT, but all the questions were of 4-point DFT only, right? So try to study more questions on 4-point DFT. So that is why I am going according to your examination process and how the question is giving you for exams. According to that only I am training you out. That is why I just thought of taking only 4-point DFT as a concept and teaching all the methodologies that comes under 4-point DFT. That is how to solve a 4-point DFT using the methodologies that comes under that, right? So that is why please to watch all these videos. Please to practice this without fail to pass their exams. I told you yesterday what to study. You have to only study this particular. Which particular? That is what I can say, your frequency domain sampling and reconstruction, and this 4-point DFT methodologies. That is your 4-point DFT with respect to matrix method, formula method, DFT, IDFT method, as well as concentric circle method, right? Yes, and then I also told you to learn on 8-point DFT. 8-point DFT, it is rare that he asks, but please do try to learn that without fail, right? Yes. So learn 8-point DFT using all these methodologies what I told you now. And once again you are going to learn properties of DFT. Its problem he might ask you very rarely, but let us do that also without fail, right? We don't know what happens, right? We can't even predict VTU. So that is why we will study that also without fail. But whatever I told till now, you have to study it without fail, right? Without fail, you have to practice like that. So your practice, your habit and method of practice will really help you a lot for cracking your examination. That is what always matters, right? How you practice, the way you give your exams, right? That is what happens, and please do make sure that you are supposed to practice things well without fail, right? Yes, that too in a proper manner, and that too you are going to practice according to your examination standards, right? If you work on your examination standards only, you get to know. You are giving a university exam and you need to know how the university is providing you the question paper, how the university people will provide you the question. You have to expect how the question comes from university. That much ideology you need to have in your mind before start practicing. It is not just blindly studying and go and write your examination, because many a times at the end you might don't have some time to practice, or he'll only provide you less amount of time for the subject to practice. So at that point of time you should have some ideology to do study during the nth moment, right? That is why I just tell you to practice according to the examination standard. That is what we are doing over here, and please do follow us without fail, right? This is DFT of x1 of n, yes, and this is DFT of x2 of n, right? Yes. If your x1 of n DFT is equal to x1 of k, and if your DFT of x2 of n, that is x2 of k, so then what is my x3 of k? That is x3 of n DFT is x3 of k. That is your x1 of k into x2 of k. So what is this x1 of k and x2 of k? You know that. So here we get only x of k for a single, what I can say, the sequence. If you solve a DFT with respect to single sequence, so you get x of k only, right? But as we are having two sequences, if you solve the DFT of x1 of n, you get x1 of k, and when you solve DFT of x2 of n, you get x2 of k, and that will result in what? And that will result in x3 of k, right? Yes. So now let me start doing the procedure. So let me take first x1 of k. So my x1 of n is 2121. So what is my DFT process? I told you that it is x4 is equal to omega of 4 into x of 4. So what is omega of 4 into x of 4? So my omega of 4 is what? My omega of 4 is 1 1 1 1 1 1 1 1 and it is minus j minus 1 plus j and minus 1 just a minute students, I'm so sorry. So it is what I can say minus 1 1 minus 1 and it is j minus 1 and minus j, right? This is what is your 4-point DFT matrix, right? This is the omega 4 matrix, right? This matrix is the same you are going to follow, right? And it is x of 4. My x of 4, small x of 4 is what? It is what is my 2 1 and 2 1, right? This one you know. So don't go into that much of complex. So you know this already and you know this already. You know that finding the DFT for one single sequence, it is just for two sequence here. That's it. There is no difference. So to follow the same DFT procedure, you are going to apply for two sequence. That is x1 of n and x2 of n. You get for if you apply DFT for x1 of n, you get x1 of k. If you apply DFT for x2 of n, you get x2 of k. And that x1 of k and x2 of k, you are going to multiply and get it as x3 of k. That is what is your DFT of two sequence. Right? Yes. That is what. So now if you multiply this is what is x1 of k students that you get. Right? X1 of k that you get students. For x2 of k, this same matrix is supposed to write and instead of 2 1 2 1, you are going to write 1 2 3 4. That's all. So you get a resultant as what? You get a resultant as it is. You are going to work it on the calculator students. I couldn't set right that still. So it is 1 into 2 as 2. This 1 into 2. So you get 2 1 2 1 only. Why? Because everything this 2 1 2 1 is multiplied to 1 over here. That is why you get it as 2 1 and 2 1. And here it is what I can say 2. This is what I can say minus j. Just a minute students. I'll just make a check. Okay. So this is 1 into 2 is 2. And this is what I can say minus j. So it is what I can say minus j2. So that is what I can say here minus 2 plus 2j, right? Minus 2 plus 2j and then you get a resultant as what? So then you get a resultant as that is 0, right? This is there is some mistake over here in the what I can say here. So it is what I can say this is 1 into 2 which will yield me to and this is minus j into 1 so which is minus j only so it is not at all 2 doesn't come into existence so please do sustain so it is what I can say like this. So if you do this you get it as 0 on the calculator, right? And here it is what I can say it is my that is what I can say here 2 minus 1 so this 1 into 2 was 2 and this minus 1 into 1 is minus 1 and this 1 into 2 is 2. So I guess you can know how to do this whole thing you have to multiply with this whole thing, that is this one you are going to multiply with 1 over here and this minus 1 you are going to multiply with this 1 over here, right? It is minus 1, that is what I can say plus 2 minus 1 and once again for here just a minute. Yes. And here it is 1 into 2 is 2 and that is j into 1 is plus j and it is what I can say minus 2 minus j. I guess you understood things, right? This whole thing should be multiplied to this particular should be multiplied to this and this particular should be multiplied to this. So I've already explained you to in a detailed manner in before videos with respect to DFT and IDFT. So please do watch that. So this resultant if you get your total resultant would be that is what I can say here 6020, right? You have to substitute in calculator and get the result then. Okay, so you understood. So this has to be multiplied to this has to be multiplied to this line has to be multiplied to this line has to be multiplied to this. So when you multiply, you get the resultant. Right, you know about all this, we have already discussed in DFT concept, right? Yes. DFT concept we have discussed, and now if I come forward, so now I got it x1 of k. So now I need x2 of k. So to get x2 of k, this whole matrix should be multiplied with what I can say, this 1 2 3 4. Here instead of 2 1 2 1, it is 1 2 3 4. So let me write. So my x2 of k is equal to, that is why I told you I'm not going to waste much time on this, because we've already discussed DFT concept and IDFT concept. So that is why I'm telling you to study first DFT and IDFT concept and then come back to this, so that you would get to know. Because to do this particular methodology, you need to know what is DFT, what is inverse discrete Fourier transform, that is in the sense the process of discrete Fourier transform and inverse discrete Fourier transform. So we have already done one problem with respect to what I can say, the DFT methodology. One or two problems, I guess three problems we have done, students. So please do watch that without fail and come back to here. So here it is 1 2 3 4, right? Yes. Okay, so now here the same process, this thing has to be multiplied to this second one also has to be multiplied to this thing has to be multiplied to this, and this thing has to be multiplied to this. So like this 1 and 1 1 1 1 has to be multiplied to 1 2 3 4, that is 1 into 1, 1 into 2, 1 into 3, and 1 into 4, and this 1 minus j minus 1 j is to be multiplied to 1 2 3 4, that is 1 into 1 minus j into 2 minus 1 into 3 and j into 4, like that. For this two also, you're supposed to do the same, right? So if you what I can say, do that, so you're going to get it as what, so you're going to get it the resultant as just a minute, students, I'm so sorry. So sorry for the distraction in the middle. So you get a resultant as what? You get a resultant as, that is equal to your, what I can say, that is your 10. I'm writing it directly. This one you need to only find it out, because I've showcased it to you for one of the problems. So let me go directly. So this is 10 minus 2 plus 2j, and it is minus 2 and minus 2 plus 2j, right? Why I am telling you to check the older videos for all this is because, so if you see one problem, you can do all the other problem without faith. See, if you do one problem DFT with respect to one problem, for all the other problems, see, the matrix method procedure is the same. There is no changes, but this numerical will vary, that's all. So that is why I told you this is for a procedure oriented subject, right? Yes, please do try to understand that clearly, and you get this resultant. So this particular part, this particular, just a minute, this particular part for this two, when you multiply, so that you have to try it, like, because we've already done it for so many, that is, we have done already three problems, DSP problems, and for that three DFT problems, and for that we have done this particular, and for now also we have done it. So this you will get it. So that is why I wrote it this, right? Yes. So now here I have to multiply what I can say, the x1 of n, and what I can say, the x2 of k, x1 of k and x2 of k. So if I multiply x1 of k and x2 of k, so what is my x1 of k? So my x1 of k is equal to, that is here, what I can say, the 6020, right? Just a minute, 6020, and 6020, and then you're supposed to write it as, that is equal to here 10, 10 minus 2 plus 2j. So what I can say, it is your minus 2j, that minus 2 and minus 2 minus 2j. right? So if I multiply this, I have to multiply this 6 with all the 4. I have to multiply 0 with this all the 4. I have to multiply 2 with all the 4, and I have to multiply 0 with all the 4. So here you can easily do it. How we can easily do it is because, so here there is two zeros. So 0 multiplied by anything is 0, right? So you get it 0 on the second one, and the fourth one is 0. You can directly tell. So now what happens is, uh, if I have to, what I can say, multiply this 6 into 10. My 6 into 10 will yield me 60, and this 2 into minus 2, which is yielding me minus 4, right? Is it easy? Yes, that is what is easier, right? So first you have to understand the DFT concept for all. So the formula, what is my formula? So my formula, this is what is my first procedure. My DFT procedure is complete, right? What I am supposed to do, I know that this x of 4 is equal to omega 4 into what I can say, that is x of 4. That is, if you can write it in a simplified version, so you get it as, that is equal to this simplified version I am writing it. So how to write for exams, I will tell you. Now for explanation, I am doing it in a, whatever is required for you, I am doing it, right? This is x1 of 4. This is x2, just a minute, I'll just check it. X1 of 0, x1 of 1, x1 of 2, and it is what I can say, my x1 of 3, right? My x1 of 3, and what I can say, which is equal to what? So that is equal to, I would be taking it as, that is equal to your this one, that is your omega 4 matrix, that is omega to the power of 4 into 0, that is omega to the power of 4 into 0 on all the four sides. That one I am going to write it now, just a minute students. So the simplified version is, that is, I'll write it over here. It is omega to the power of 4, omega 4 of to the power of 0, omega 4 to the power of 0, and omega 4 to the power of 0. And here it is omega 4 to the power of, what I can say, once again it is the 0, right? Yes, here it is omega 4 to the power of 0. Here it is omega 4 to the power of 0. And here it is omega 4 to the power of 0. Yes, and then once again it is what I can say, omega 4 to the power of 1, omega 4 to the power of 2, omega 4 to the power of 3. So it is omega 4 to the power of 2, omega 4 to the power of 3. This is omega 4 to the power of, what I can say, just a minute, my 4 is going to be. Okay, omega 4 to the power of, what I can say, 4, and omega 4 to the power of 6, and it is omega 4 to the power of, what I can say, the 3 2s are 6 once again, and omega 4 to the power of 9, right? Yes, so this is what is your matrix. So this into, so this matrix, what I can say, the into, so that is equal to what? So that is equal to your x2 of 0. It is x1 students, x1. So x1 of 0, x1 of 1, x1 of 2, and x1 of 3, right? Yes. Yes. So this is what is my simplified one. That is, this is for x1. If you have to write for x2, wherever we have written it as 1. So here, here, here you have to write it as 2, right? And here also we have written x of 1, right? Here you have to write it as 2, that's all for x2 matrix, right? For x2 matrix. So how to represent this for exam is that, just a minute. So first you are going to write the given two sequences are these two sequences, and then you are supposed to write, if your x1 of n is DFT, x1 of n DFT is x2, x1 of k and x2 of n DFT is x2 of k. So my x3 of k is equal to x1 of k into x2 of k. That is supposed to write, and then you're supposed to write this formula. So now to find DFT of x1 of n, you're going to write, and you're going to write this formula, and you're going to simplify this by writing like this, and then you're going to write your omega matrix is equal to this particular matrix, and then this whole x1 of 0, this one is equal to this particular, and then you're going to multiply. So that is why I'm going to share this particular in the YouTube, so you can just check it out. Okay, yesterday also I've shared few of the things with respect to control. Please do see that without fail, right? Yes. And now why I'll share this to you is because in that format only I'm going to write it for exam. But for what I can say, but for now, as I'm teaching you things, so I'm going to write it in a teaching manner, and I'm going to teach you. For exams, I'm going to share the sheet, so please do follow that and write the same order in your examination. I have also written in the same manner, so please do try to write it, right? This is what is my x3 of k now. Yes, just a minute. Okay. So now I need my IDFT. So what is my IDFT? So I have written on formula for IDFT, wherein that is equal to what? So wherein that is equal to x of n is equal to what? That is 1 by n into omega n. That is what I can say, the omega n star into x of n. Omega n star in the sense it's opposite of that particular DFT, right? Omega 4 matrix is somewhat different than the DFT matrix. It is different for IDFT matrix. That is why he have given omega n star. This is into x of n. So this x of n is what? This x of n, please do remember, this x of n is what we got now. That is what is 60 0 and your minus 4 0, right? That only you are going to multiply. 60 0 minus 4 into 0, right? That is what I am trying to tell you, right? Yes, so that matrix is supposed to write it over there, right? Yes, and next, yes, okay. And next, now let me solve according to this. So let me come back. So I'll write it as, for my IDFT, for my IDFT, it is what I can say, the x of n is equal to 1 by n into, my n is 4 now, right? Because it is omega 4 to the power of, that is this omega 4 matrix, right? Yes, so my n is 4, therefore I'll directly write it as 4. But here, for the formula purpose, let me write it as n. Just a minute. N into x of n, right? Yes. So according to my formula, it is 1 by 4 into, I know what is omega of n matrix, right? That is 1 1 1 1 1 1 1 1, and this is j minus 1 minus j. This is what I can say, minus 1 1 and minus 1, and here it is what I can say, the j minus j, what I can say, minus 1 and j, right? Yes, and this is what, and here it is what I can say, the 60 0 minus 4 and 0, right? Yes, so now if I, what I can say, do the process. So what is the process? This you have to multiply to this, and this you have to multiply to this particular you have to multiply to this, and this particular you have to multiply to this. Here this is really easy. Why you have got a 0? So that is why you will get it resultant easily. That is, here it is what I can say, 60 0 plus 4, 60 plus 0 plus 4 plus 0. Okay. Just a minute, students. Yes. So now here it is 64, that is 1 into 60 is 60, 1 into 0 is 0, 1 into minus 4 is, this is minus 4, and 1 into 0 is 0, because all 1 1 1 1, the very first line is getting multiplied to 60 0 minus 4 0, right? And now if I take my second one, so for my second one you get it as, once again it is 60 So here it is 60 because this line is 1, the beginning number is 1. So therefore 1 into 60 is 60, 1 into 60 is 60 and this 1 into 60 is 60, right? And it is once again it is 0. So what I can say plus 4, it is what I can say, that is what I can say, your 0, right? What it is minus 0, and here also it is the same. Here it is minus 1 into 0, which is equal to what I can say, that is your this one, that is 0 minus 0, and once again here it is minus 4, and once again here it is minus 0, and then here it is 0. I guess you can understand the calculation part, right? If you don't understand, I'll retell the calculation part again for you without fail. I'm working on it, right? Yes, and this is minus 0, and this 1 into what I can say minus 4 is plus 4, and once again it is what I can say 0, so that is my plus 0, right? Yes. How is that? This one I already told you in the before now itself. So this one gets multiplied by 60, this minus j gets multiplied by 0, this minus 1 gets multiplied by 4, this j gets multiplied by 0, right? That is what I already told you, right? Yes. So now here if you do that, so you are going to get it as, that is equal to, so you get it as what? This is, you are going to suppose to write 1 by 4 into that particular, right? So you get, just a minute, we'll just call it up. Yes, just a minute, I'm so sorry. Yes. So now it is what I can say, the 60 minus 4 is what? So 60 minus 4 is what I can say 56, right? 56, it is the 64, 56 and 64. If you have 56, 64, 56, 64, and what I can say, if you divide by 1 by 4, so what 4 is 56, right? What I can say, it is your this one. Which one? Here it is 14 fours of 56, right? You know, right? Yes. What is 14 into 4? So 4 fours are 16. 1. So 4 into 1 is 4, 4 plus 1 is 5, 56. And here once again it is 16 fours are 64. It is 14 fours are 56, 16 fours are 64, and you will be getting it as, that is equal to 14, 16 and 14, 16. Right? Did we get the same in what I can say, my this one concentric circle method? Yes, I got the same in concentric circle method. That is what is I am getting it as, that is x3 of what I can say, the n, right? X3 of n I got it through concentric circle method. So you just see which method is easier for you. In the sense, he might ask you any of the method. That is why don't fix into this particular method itself. That is why I am telling you many a times, don't go into a fixed mind. Don't fix any of the method in your mind. It is really wrong, and you will what I can say, you will fail in that particular point, because he VTU examiner, the one who said the question paper, he doesn't have any methodology in mind, right? He might give you any of the methodology for your exams, right? He might not ask a question, find DFT of the following sequence or find IDFT of the following sequence, without giving any methodology, right? He will specify some methodology for you to do. So that is why I always tell you to learn all the methodologies without fail, because of this reason, right? So for example, if you are feel that my matrix method is easier, and you just stick on to matrix method and you just solve all the things using matrix method. Let me assume that as an example. And when you see the question paper and when you see that your question is a concentric circle method, then you fail, right? That is why I always tell you to learn all the methodologies, because you don't know which methodology you get for your exams. It is up to the examiner or the question paper setter who sets the questions, right? That is why please do try to learn all the methodologies without fail. I have showed yesterday you the question paper. You can see there was concentric circle method, right? And there was what I can say, the matrix method also, and there was your formula methodology also, and there was DFT IDFT method also. So that is why I tell you to learn all the method without fail, without any hurdles, right? So now let me get back to this question and let me discuss this once again. Yes. Okay. I'm so sorry. Yes. So now my sequence is given as x1 of n and x2 of n as 2 1 2 1 and 1 2 3 4. So why did I take this particular only? What we did yesterday is because I need to prove that from both the method you get the same resultant, right? Because if I take a different one, then it would be quite different, right? That is why. Quite different in the sense you don't get to know the things well. That is why I just took the same resultant, same question, right? Yes, and I need to find using DFT and IDFT method. So this is completely based on matrix method. You don't need to use formula method over here. So for this particular, you have these two equations. That is your x of 4 is equal to omega 4 into small x of 4, and this x of n is equal to 1 by n into omega of n omega of n star into capital X of n. So if you know these two things, so you would easily crack your what I can say this particular topic if he gives in the exam. You need to know first these two things, and you need to know this particular, that is if your DFT of x1 of n is x of 1 of k and DFT of x2 of n is x2 of k, then your x3 of k is equal to x1 of k into x2 of k. That one you need to know, right? Then what is supposed to do? Then you are going to write, let us compute the DFT of x1 of n. So let's compute the DFT x1 of k. So if you compute the DFT of x1 of n, that is x1 of k, you have to write like this. That is what you have to write very first. You have to write the formula first. Then you have to write the simplified version of the formula. That is this simplified version of the formula. First you have to write this formula, that is x of 4 is equal to omega 4 into x of 4, and then you are going to write the simplified version in the next step. In the second step, this whole thing is supposed to write, and after that you are going to write my omega 4 matrix is this and my x of n is this, and you are going to just write this step. You are going to write this step, and then you are going to write this step and then the resultant, right? And then for x2 of k also the same. You are going to write the formula, then once again you are going to write a simplified version of the formula, that is this simplified version, that is instead of 1 here you are going to write 2 for here also and for here also. And now what is supposed to do is, so you are going to, what I can say, do the next step of this, and you are going to write this resultant. And then once again you are going to multiply both x1 of k and x2 of k and write this resultant. So how did you get this is that you have to multiply this 1 into this 1 into 2, 1 into 3 and 1 into 4, and this 1 into 1, and this minus j into 2, and this minus 1 into 3, and this j into 4, and this 1 into 1, this minus j into this 2, and this 1 into 3, and this minus 1 into 4, and this 1 into 1, this j into 2, this minus 1 into 3, and this minus j into 4. So this thing you have to multiply and get this resultant. So this you are going to do for the upper one also, right? After you get this resultant, now we know this formula. This is 1 by n into omega n whole star into x of n. So this is my n is 4 because my samples are 4 samples. That is why. So this 4 into what I can say, this matrix, that is IDFT omega n matrix into that x of n that we got it over here. And if you simplify this by multiplying what I told you in the before, so the same thing you're supposed to do, you get it like this. And what is the resultant that you get over here, that you have to divide by 1 by 4, and you get it as 14 16 and 14 16. So this is what is the resultant, right? So your concentric circle is minimal times is asked that particular, but maximum times is asked DFT and IDFT method, your matrix method, and what I can say, a formula method, right? I know how the question comes, that is why I'm telling you. So your DFT and IDFT method is most important. Your what I can say, the properties of DFT is the most important. Your matrix method is the most important. That your 4-point DFTs are the most important. You haven't asked 8-point DFT. You can just check with this only. I'll just open with the question papers for you all. So yes, I'll just a minute. So let me clear it because I don't want anybody to just see here. It is 4-point DFT, right? This is also 4-point DFT, right? N-point DFT has asked you for your exams. Let us do that in the next session, right? See, this is x of n and this is x of n. This is 4-point DFT. Once again, if I come back to what I can say, this is what is my July. Okay, so let me come to this. So if I take this paper, see, is asked endpoint DFT. This is 4-point DFT, right? And if I come to the other question paper, I'll come to, I'm sorry students, yes, just a minute, history, and yeah, this is over. See now, here you can see endpoint DFT. This is 4-point DFT. This is also 4-point DFT. Can you see? Yes. And then if I come to what I can say, the other last question paper. See here, this is 4-point DFT. This is DFT and IDFT methodology. So this is 4-point DFT using matrix method, right? Yes. And this is endpoint DFT, right? Yes. So what I'm trying to tell you by all this question paper is that, so you have to, what I can say, work it on, right? You have to work more on 4-point DFT than on 8-point DFT. Your 4-point DFT is a really important factor for your examination. See, whatever the question paper I showed you now, in all the question paper it is 4-point DFT only, nowhere you saw 8-point DFT. One question from 5-point DFT that I already told you in the yesterday's class, right? This particular, see, this is 5-point DFT, this one. This one is only 5-point DFT. All others are what? All others are my 4-point DFT only. So just try to practice questions on 4-point DFT. If you see a textbook for your 8-point DFT, the questions are really less. Your 4-point DFT, your 4-point IDFT, your endpoint DFT, and your concentric circle method and IDFT method, your 4-point DFT questions are only more. So that is why try to, what I can say, work more questions on 4-point DFT. That is why I am concentrating on 4-point DFT. I guess you got my idea why I am concentrating only on 4-point DFT and I am teaching all the methodologies on 4-point DFT, right? Your 4-point DFT questions are really important. Please do start practicing your 4-point DFT questions without fail in any methodology that you see, right? Yes. And that is what I was about to tell you for today's session. And I guess you understood this multiplication procedure. So I'm going to now showcase you once this particular question in the textbook, and then I'm going to share this picture, right? The photo in the YouTube, and you can just look at that. And this is what is for today's lecture, and thank you.